Hi everybody, this is Gigi from Kauai Community College. In this video, we will be talking about the types of arguments and to use Venn diagram to evaluate an argument. So let's get started. Okay, so in this video, we will use Venn diagram to evaluate arguments. But before we start with that, we want to take a look at some definitions. A statement is a complete sentence that can either be true or false. Can either be true or false, but not both at the same time. Okay, so the true or false are what we call the truth value of that statement. Now, an argument is a set of statements that use facts or assumptions, that's what we call premises, to support a conclusion. Okay, and the structure of an argument will look like this. We'll have premise 1, premise 2, 3, 4, and so on. And then it will have a conclusion. Okay, so that's how it works. Now, the types of argument. You will either use what we call inductive reasoning or deductive. Inductive is when you make a case for the general conclusion from more specific premises. We cannot be certain that these conclusions are true, but can determine the strength of the argument. Then deductive reasoning would be the other way around, is when you make a case for a specific conclusion from a more general set of premises. Okay, and we can determine when you use deductive reasoning, we can determine if the argument is valid in structure, and then once it's valid, we can determine if it's sound. Okay, so let's see what deductive reasoning look like. Okay, so you've seen stuff like this in math, right? Seeing a pattern. Okay, that's what we call inductive reasoning. Right? It's a very powerful thing to do in math, to see patterns so that you can make a conjecture of what might happen in a general case. Okay, and that's what we call that conclusion is also sometimes called a hypothesis or an educated guess. Okay, or you might see an inductive argument that looks like this. Premise 1, 2 plus 3 equals 5. 5 plus 4 equals 9. 7 plus 6 equals 13. So the conclusion is that the sum of an even and an odd integer is an odd integer. So here we are using specific example, right? To make a conclusion for a more general case. And that's what we call an inductive argument. Okay, now in this case, the premises are true, so the argument is moderately strong. And we can further, if we use deductive reasoning, we could actually prove that this conjecture is true. Okay, so, but as far as this inductive argument goes, we could say that it's moderately strong because the premises are true. Okay, deductive reasoning. Okay, deductive reasoning is when we could actually judge the validity of the structure. Okay, and a deductive argument is valid when the conclusion necessarily follows the premises, okay, regardless of the truth of the premises or the conclusion. And in this video, we will use Venn diagram to judge whether an argument is valid. And then later on, we will use what's called a truth table to analyze it. Okay, so valid is when the conclusion necessarily follows the premises. Now, an argument is considered sound when it is valid in structure and that its premises are true. And note that the conclusion that is proven to be true using deductive reasoning is called a theorem, as opposed to when you use inductive reasoning, that's called a conjecture or a hypothesis or an educated guess. Okay, so that's the difference between the two. Now, let's remind ourselves of the types of Venn diagrams with two sets. Okay, remember this, right? That is what we call a overlapping. Okay, and in this case, we say some members of B are in A, or we would say some of A are in B, or we could say some of B are not in A. So, but the this one right here, the second one, is what we call a two disjoint sets, right? And how we would say this is no members of B are in A, or no members of A are in B. And then the third type is the subset, that in this scenario, we would say all members of B are in A. So these words here, the some, the no, and the all, are what we will later name them as quantifiers, but we'll deal with that later. Okay, so now those are the type of Venn diagrams that we're going to use in order to determine if a deductive reasoning is valid. Okay, so here's an argument. Unicorns are awesome. Unicorns are very awesome. Look at them. Gigi is awesome. Look at me. I'm awesome. I created a whole virtual classroom for you. Therefore, Gigi is a unicorn. So in this argument, we want to see if it's valid in structure. And then once we determine that it's valid, we want to see if it's sound. Okay, so premise one is unicorns are awesome. Premise two is that I'm awesome. Therefore, I'm a unicorn. All right, well, let's see. We will go ahead and think about the type of Venn diagram this is. So there are two sets, unicorn and awesome things. So when people say unicorns are awesome, is it going to be an overlapping? Do they mean some unicorns are awesome? Do they mean all unicorns are awesome? They obviously don't mean no unicorns are awesome. So disjoint is not even a choice here, right? So, but in this case, they really mean, when we say unicorns are awesome, we mean all unicorns are awesome. So it is a subset. The interior is a set of unicorns, and the outside circle is a set of awesome things. Now, when someone say that Gigi is awesome, where could she be? Could she be in there? Yes, because inside a small circle means inside a big circle. And all awesome things are inside that big circle. So as long as we mark it inside a big circle. Well, okay, right? But is that the only place she could be? No, she could also be in the outer part right there. So is it necessary that Gigi is a unicorn? No, not if she's out here, right? So not if she's out here. So does the conclusion necessarily follow the premises? And the answer is no, it doesn't have to be. She could be here or here. So it's not valid. Now, once it's not valid, we can say not sound. Okay, because in order to be sound, it needs to be valid in structure first. Okay, so in this case, no, this argument does not prove that Gigi is a unicorn. I'm not a unicorn. I'm so glad I'm not a unicorn. I'm a math teacher. All right, here's another argument for you to look at. Some paintings are beautiful. Mona Lisa is a painting. Therefore, the Mona Lisa is beautiful. Okay, let's see. Premise 1, premise 2, and the conclusion. What would it be? Overlapping, disjoint, or a subset? Okay, pause the video and draw your Venn diagram. Okay, your two sets would be paintings and beautiful things. Okay, so what do we say? Yes, it's an overlapping, where one set would be paintings and the other one would be beautiful things. Okay, so where is the Mona Lisa? It's a painting, so it could be anywhere inside the red circle, right? That means it could be here. It could be here, inside the common part, the overlapping part, because anything inside the red circle is a painting. So what do we say? Valid or not? Does a conclusion necessarily follow the premises? The answer here is no, because the Mona Lisa could be here where it's not beautiful, or it could be here where it is beautiful. So you couldn't necessarily conclude one way or the other. Okay, so this is not valid. And when it's not valid, it's definitely not sound. Okay, here's an argument. All politicians are married. Mayor Cavallo is a politician. Therefore, Mayor Cavallo is married. Premise 1, premise 2, the conclusion. Okay, overlapping, disjoint, or subset? And you're right, it's a subset. Go ahead and pause the video to draw your Venn diagram and determine if it's valid or not. Okay, so the interior circle would be all politicians. The outside circle would be all married people. Mayor Cavallo is a politician, so where can he be? Anywhere inside the small blue circle. Anywhere inside the small circle. Okay. Could he be placed outside of the blue circle? No, because he's a politician. Inside blue are politicians, outside are not. Okay. So once we determine that he must be inside that blue circle, And we can say that anything inside that blue circle is also inside the big red circle. So he is married. Is it valid? Yes, it is. Is it sound? Well, this argument is sound only when the premises are true. So your job here is to evaluate the premises. Okay, so let's take a look at the premises. Do we think all politicians are married? No, not true. This is false. And once we know that one of the premises is false, we can say that the argument is not sound. A sound argument is when it's valid and the premises are true. Now, how do I know it's false? You can go and Google it. I'm sure there's a list of, I don't know, the top 10 bachelor politicians for you to look at. But we know from common sense that not all politicians are married, right? So it is not sound. Okay, that is it for today.